Hello everyone and welcome back. So with this session we will talk about profiles on Big IP. We have multiple types of profiles that deal with different protocols, different functions on the Big IP. Profile is a way that Big IP allow us to change the parameters of protocols, be it application protocols like HTTP, FTP, SIP, and SMTP, be it TCP, the layer 4 protocol, UDP, or some functions like persistence, or if you would like to call it stickiness. We will go through it in the upcoming slides. Other profiles, like if you want to integrate the Big IP with the Active Directory authentication. So before people access the virtual server, you want to authenticate them against LDAP or Radius or TACACS or whatever. Other profiles like the encryption, things that we will do also during the upcoming sessions. How to enable SSL encryption on the virtual server or the web application. Now, before going through the details of the profiles, let me just quickly remind you on a whiteboard how we utilize the profiles. So remember that we said that the Big IP will act in a full proxy mode. So we have server 1, server 2, server 3 hosting our web app. We have inside and outside connecting to a cloud, WAN or internet or whatever, and then we have client who is consuming our web app. Now on the Big IP, we have the virtual server serving our application. Now, if you recall that the Big IP will act in full proxy mode, means when the client connects to the virtual server, there is a TCP connection, and then there is a separate TCP connection from the Big IP to the selected server. Let's say in this example, server 1. So we have another TCP connection, separate TCP connection. Having two separate TCP connections provide us ability to have different TCP parameter on the server side, different TCP parameters on the client side. Any parameter like window size, like any other feature you want to enable or disable within the TCP protocol, you can do it either on both sides or on one side. So you have the flexibility if you want to change something between the Big IP and the client. You have the flexibility to create a TCP profile, customize the parameters you would like, and assign the TCP profile to the virtual server so that any client connecting to the virtual server will be using the customized TCP settings that you have configured. A very common case on the WAN optimization that Big IP can do, and the WAN compression that Big IP can do, the window size as well, because usually the Big IP and the servers, they sit in the same data center. So the connection between the Big IP and the real server usually is very good connection. Speed maybe 10 gig, there is no latency, network round trip time. So the connection is very good, but the connection between the virtual server and the client, usually it is WAN or internet even. So the latency and delay is very high. This is where the Big IP will increase the window size on the client side to accommodate the latency, but on the server side, there is no need to increase the window size because already the latency and the delay is very low because we are sitting in the same LAN. So these type of things that you can do using the profiles to customize protocol settings. For example, we mentioned it before. I can assign SSL profile on the virtual server so that I have encryption between the virtual server and the client. But at the same time, between the big IP and the server, it's still HTTP. So maybe within the data center, you don't want to encrypt. Maybe you have an IPS here that you wanted to see clear text, for example. So still you can encrypt between the big IP and the server. So you have client-side profile encryption and you have server-side encryption as well. Another example is the HTTP version. We discussed this also in previous slides. So you may have HTTP version 1.1 here and HTTP version 2 here, for example. So the profiles, the protocol profiles and the application protocol profiles gives you the flexibility to customize the profile parameters and configuration between the big IP and the client. Let's go and see the TCP profile. Let's test the TCP profile. Let me, this is our testing machine. Let's go to the big IP. So local traffic profiles protocol TCP profile. There is a default TCP profile that ships with the device, and you can see that there are customized TCP profiles, TCP1. This is where the WAN optimization features enabled, but this is beyond the course that we're doing now. Let's create new profile, call it our TCP profile. The parent profile is TCP, so we inherit all the default configuration from the TCP profile. Now, what I wanted to change in this profile is time to live, for example. As you know, the default time to live is 255. So when a client sends a packet toward the server, the time to live will be 255. As it passes different layer 3 devices, each layer 3 device will decrement the time to live by 1. So maybe if you have like 3 routers, the packet will arrive to the server decremented by 3. And the response from the server comes back to the client will come out of the server with 255 and then decremented on the way, maybe 3 or 4 routers, depends. Now, what we can do here is we can configure the big IP to reset the time to live. So I don't want to proxy the time to live that is coming from the server or the client. I don't want to preserve, I don't want to decrement, I want to set a specific value. So I want to set to, for example, 133, or let's set 222. It's any value between 1 and 255. So as the traffic flowing between the user and the server, I want to set the time to live to 222. Let's test this. Click finish. So we have our profile. Then we have to go to the virtual server, our virtual server, and change the client profile to be our TCP profile. Now, before I do that, before I click update, let's go to the testing machine. Let me open the Wireshark so that we can see the packet. Let me capture on the lab interface. and click on the, so we have the server, we have packet cap. So let me stop the capture. Let's take the first packet and let's look at the time to live. So as you can see, it's now 128. So the Windows, because this packet is initiated from my testing machine going to the virtual server, the Windows initiated traffic is 128. Let's see the response. It's 255. So the big IB, it uses the default time to live value as 255, while on Windows, the Windows behavior is 128, as you can see. Let's see if we apply the profile, let's click update. Now the profile is applied to the virtual server. Go back to the testing machine, start the capture again, refresh the page, come back here. Let's see that the time to live for the first packet from the user to the server is still 128 on the Windows. Let's see the response. Now you can see the response time to live is 222 from the virtual server toward the client. So using the TCP profile, we were able to change one of the parameters, which is like 222. If I go back to the profile, another setting that we can test with the TCP profile is the IP type of service. So this is where you agree with the network team that you want them to prioritize the traffic for this virtual server, give it more priority. So because this is a business critical application, for example, so you agree with them that you will tag or you will mark the traffic for this virtual server as DSCP 5. So you mark as a DSCP 5. Now, before we do that, let's see on the packet capture what is the default DSCP mark that will be applied before we apply the changes. So let me start fresh packet capture on the client machine, testing machine, and let's refresh. We have page open. Let's just refresh, then stop the packet capture. So the traffic going from our client to the server, if you see on the DSCP, it's CS0. Let's see the reply. It's still 0, DSCP 0 from the virtual server to our client machine. This is where we should see the marking is different now when we apply the marking on the virtual server side. So let's go back to the big IP toast 5. Let's click update. Now the server is the profile, sorry, is already applied to the virtual server. So we just need to update here. Let's go back. No, let me first start the fresh capture again. Let's open a new Firefox window. So 192. Okay. Go back to our shark. Stop the capture. Now from client to server, DSCP is still 0. No problem. Now from server to client, the reply, now we see that the DSCP is 5, is marked as 5. So this is where the network team will prioritize the DSCP 5 marked traffic so that our virtual server will have priority over other non-critical traffic. Other things that we will test the TCP idle timeout in a different session. I will show you how to customize or to change the TCP idle timeout and other consideration for that. So that's it for the TCP profile. See you in the next session. Thank you.